for getting us back on track so quickly. So thank you so much for that. All right. I am gathered here this afternoon with two of my favorite people. First one, Jay Rodge with NVIDIA and Philip Kiely with Baseten. So great to have you guys here on the show to talk about cool things with cloud.
Yeah,
Hey,
really
thank you for
excited.
having us.
All right. One of the themes that we've been hearing, starting off with Thomas's keynote today, is really about inference. And so, there's so much going on that. Jay, maybe I'll start with you. What are some cool things that maybe NVIDIA and Google Cloud are doing to make inference better for users? Hint,
Yeah.
hint.
Yeah, sure. So I'd like to share two most important announcements from today of Google Cloud partnering with NVIDIA. So the first one is Google Cloud will be one of the cloud providers to have Vera Rubin, which is the next generation NVIDIA hardware for inference and training. So this will be coming later half of this year. And Google Cloud are also adding Blackwell GPUs, which is RTX PRO 6000. So the key benefit of that GPU is it has 96 gigabytes of VRAM, which helps you deploy or add multiple models on a single GPU, which is insane.
Can I have one of those for my basement computer? Maybe?
Sure. We should talk later.
Yeah, just if I pay you for it, right? If I pay Johnson for it. Philip, so inference.
It's
What
everything.
does that mean to you?
To me, what inference means is being able to actually deliver on the promise of AI applications. It's one thing to train the world's best model or fine-tune a model that is amazing at a specific task. But if you want to build a low latency, high reliability user experience and scale it in the sort of hypergrowth fashion that all of these AI platforms are going through these days, then you need really fast and really reliable inference to make that happen.
I think it's cool, like just how we're seated. We kind of have infrastructure, we have models or GPUs, and we have the application on top of it. It's super cool to see all this.
Full stack seating chart.
Full
Start.
We should trademark that. That's a great comment there. All right, so let's kind of bring this back. So maybe starting with you, Philip. You obviously are with Base 10. How are you using the stack? If you kind of walk back to this way, like how are we doing inference at scale for so many cool things? Because you're running billions of inferences, and I don't remember the specific type rate, but it is a lot on kind of customized things.
Yeah, we like to be a little vague about it, but it's a lot of inference. We are very closely partnered with NVIDIA on a bunch of things, both on the hardware and the software side.
Yeah.
We were one of the first users of NVIDIA Dynamo for inference. I actually remember, the week after that GTC keynote last year, it was like, we called them up, we're like, hey, we're using it in production and we've got a couple questions. And they were like, you're doing what in production? And then, obviously big adopters of Blackwell for inference.
Yeah.
There's a lot of work that goes into migrating an inference system from Hopper to Blackwell on the software layer, on the kernel layer. We've been doing a lot of that, a lot of stuff with NVFP4. I was just doing a talk at AI Engineer Miami a couple of days ago where I was talking all about the different quantization frameworks that we're using with NVIDIA. Obviously on the hardware side, any GPU we can get our hands on, we're stuffing models on there and making them run fast. And that get your hands on part comes through Google Cloud. So Google Cloud is one of our cloud providers. We sit on top of Google Cloud GPUs, use GKE to build our systems. And one really cool thing that we do with Google Cloud is that we are a sort of multi-region deployment.
Oh, so, that's cool.
Yeah, we can take GPUs in America and in Europe, around the world, collect them into a single sort of unified pool of compute, route user requests to minimize latency, and just generally make sure that you're able to access all of the compute in the world, not just what's in whatever one region or one system that you're working in.
That's super cool. So one of the things is you think about running these things. I know you also do a lot with Gemma, which is one of our essentially our premier open source model at this point, which is super cool. How are you training Gemma with all of the stack here, and what are you doing with it? That's super cool, because you just mentioned a lot of things that we could dig into.
Yeah, so we were day zero support partners for the Gemma 4 launch, and I remember back when the first Gemma model came out, and then Gemma 2,
Yeah.
Gemma 3, what I've always appreciated about this family of models is a few things. Number one, the multimodality.
Yeah.
Having a model that does native image inputs is huge for a ton of use cases, especially a lot of enterprise stuff, like KYC and document extraction, all those kind of things.
Yeah.
And then the other thing that I really admire about the Gemma family is the range of sizes. We've increasingly been seeing companies fine-tune open models to build task-specific intelligence rather than relying on an out-of-the-box model. And the Gemma models, all the way from 2 to 30 billion parameters, provide a really wide range of sizes that sort of other high-end models, a GPT OSS 120B, for example, is a fantastic model, but it's too big for a lot of use cases. And that's where having that range of smaller models is really, really essential as basis for fine-tuning.
Yeah, you don't want to played a little bit with like the what's the Gemma 4? It's the MOE model. It's the 4 billion MOE. Like it's crazy, the activation on that in terms of just what it can pull off. Jay, you mentioned like all these cool things that we're launching together. How should users think about different methods for changing model sizes based on kind of the GPUs that they're looking to get, and then kind of that scale factor on inference. How to make it the fastest, most performant thing for them. What do you usually coach developers on as they think about these things?
Yeah, that's a good question. So if you want to optimize inference, we work closely with all the model providers, including Google DeepMind for Gemma. So what I usually recommend is them trying out TensorRT LLM, which is an open source LLM optimization inference SDK. So with just a couple of lines of code, you can get the best performance available on any kind of NVIDIA hardware. So we had day zero support for Gemma 4, and we work closely with Baseten in order to scale that.
That's super cool.
Yeah, with NVIDIA Dynamo, which is also open source. So those are the two things that I recommend. There's also NVFP4, which is a precision format by NVIDIA. So if you have that model checkpoint in NVFP4, it will give you the best performance in addition to TensorRT LLM optimization. And if you have a Blackwell GPU.
That's super cool. So, Philip, I think you have a demo for us.
I do. We're going to run some models.
Let's do this because we're talking full stack podcasts here. Let's see a full stack in action.
All right, let's pull it up here. All right, I'm seeing.
And Jay and I are your demo quarterbacks for this.
All right, sounds good. Well,
I've got my chair ready.
I'm the quarterback. I'm going to throw you some passes. Let's score some touchdowns here. So this is Base 10. Base 10 is a inference platform. We focus on high reliability, low latency inference at scale.
Okay.
And I have a little demo platform here. Some of this stuff is real, some of it's simulated behind the scenes, just because I didn't bring 1,000 B200s with me today, but I'm going to show you how it works and when you have them.
You don't have 1,000 just in your back pocket?
I mean, we got them. They just didn't give them to me. Something like a customer needed it for a mission critical workload. I don't know.
Those customers, man.
Yeah. So we're going to...
We love our customers out there. I love the customers too. I'm just making a joke.
Yeah, we all love customers.
So, this is a actual Base 10 account that I have here with a bunch of models deployed in it. One of them is the new Gemma 4 model, and I actually have the smallest Gemma 4 model just to show how capable these models are. So, Gemma 4, this is the E2B model. It's pretty tiny, but it has a bunch of great capabilities, including vision inputs. And, to take any open model from Hugging Face, we actually have this one pre-packaged, so we have it ready to go. You can just do one-click deploy. And what that looks like, here you just put in your Hugging Face access token, get a GPU. I've got it on an L4 just to show you can scale these models down quite a bit. And what that looks like when it's deployed is you have your production deployment. You can see your logs. You can see, everything that happened to kind of spin up this model, everything in terms of pulling the weights, building that optimized engine. And then you can also just try running the model. So I'm going to give it here this little dog picture and ask what it is.
It's cute.
And, sure enough, a black Labrador puppy with expressive look on its face. I don't know, I'd say that's a pretty expressive look on its face.
I think that dog's hungry.
Yeah, I mean, probably. I'm hungry. It's 12:30. But yeah, so you can basically run this model and get a OpenAI compatible API endpoint. Now that's all like pretty straightforward. Just being able to put a model on an L4, run one prompt. That's not a groundbreaking revelation at all. The point of this platform is scale. So if you look at, I've got this GPT OSS 120B demo up. The point is the auto scaling, being able to scale up to hundreds or thousands of replicas of a model to handle large amounts of traffic. When you have that, we add in the metrics page where you're able to see as your inference volume goes up and down, your replica count goes up and down with it, and that keeps your response time steady, even as you double traffic and scale it back down over the course of an hour.
So as a developer, I don't have to worry about scaling.
Exactly. You just, with these dedicated deployments, you throw as much traffic as you have at it, and it scales up and down within the parameters of the system. You can set things like, your window, your scale down delay, concurrency target, all that kind of stuff. And it just does it for you.
Yeah, I love the the notion of an application developer like moving up the stack and the metric side. Hey, does it work is great, but can I actually maintain like some level of SLA with the application, the LM? I think that's critical, right?
And that's what we do. Like we are in the we're in the business of meeting SLAs, both on latency and reliability. And then the last thing I just wanted to show really quick, because I'm obviously here to talk about Gemma, but I'm also a huge fan of the Nemotron models from NVIDIA. So maybe you don't need 20 B200s for a given workload. Maybe you just need a handful of tokens. That's why you can hop over to our model APIs, which are traditional like pay-per-token APIs. Nemotron Super is a very efficient model, so we're able to offer it at a very, very affordable cost. And you can, again, just like get an API endpoint that you copy into your application and run these models on a per token basis with all of these inference optimizations we've been talking about already built in. So with Base 10, like you can, of course, go in and configure your own things. You can use TensorRT LLM or any other inference engine within the Base 10 inference stack. You can, configure your model and then, deploy it over to the thing we were just looking at.
How do you suggest GPUs? Like which GPU should I use as a developer?
That's a great question. So, I showed these demos on a few different pieces of hardware. I think that for me, the big thing is just matching it to the workload and then making it as cheap as possible. Okay. And the funny thing is that like when you do large scale workloads, as cheap as possible does not actually necessarily mean the cheapest GPU. Yeah. Because if you have a GPU that costs twice as much, but it handles 3 times as much volume, you don't need as many GPUs to run your workload, and thus you actually lower your TCO at scale.
Yeah, sharding, like model sharding and all that. I mean, there's a whole nother like discipline of LLM engineering that's off that. So one of the things I think you mentioned we actually haven't talked about yet today is Google Kubernetes engine. Yes. Essentially our managed runtime for Kubernetes. How are you using it, and what cool things are you doing or features are you specifically using within it?
Yeah, well, I'm much more of the inside of the GPU guy versus the between the GPUs guy. But I know that one thing that we've really appreciated about the Google Cloud infrastructure is the low latency between models. Yeah. A lot of times what our customers are building is not just one prompt in response to a single model, it's an agent, it's a multi-model compound AI system. Yeah. And for that, having at the infrastructure level very short turns in between one model to the next, like, solving the hairpinning problem. I know that GK did a great job of that. It saves us, a couple dozen milliseconds every turn between models. And if you add that up over an agent where you might talk between a model dozens of times, that can actually lead to real latency savings. So that's a great feature of GKE. The other thing is just the flexibility and scale. We are running massive workloads for our customers. This one that I had up with like 22 B200s is actually a relatively small demo workload. Yeah. And being able to access, that flexible capacity via GKE is really massive for us.
Yeah, what I love, I have done admittedly less with Kubernetes over the years because I started off in Cloud Run, and like once you're there for doing a lot of like DevRel work, I mean, it's hard to like go off of that just because it's like click a button and like then it goes away and it runs. But with LLMs, like using Kubernetes and like even setting it up, like it is so easy to have something like Gemini say, hey, here's your manifest, here's the model, like, oh, just go deploy it. Yeah, it's like magic. And it's like it's so fun to see that. Philip, you wrote a book.
I did.
I have it right here. It's Inference Engineering. I'm super excited to read it. Maybe tell us what's it about, what are you covering, and what's one thing in here that if I read it, I would be like, like that's pretty cool.
Yeah, so I joined Baseten actually more than 4 years ago, and I've been working in this inference space since we were doing, XGBoost models on T4s and Whisper, the original one on A10Gs and that kind of thing. So I've seen this space evolve and had the privilege of learning all of these topics in practice over the last few years. I realized as I was helping new teammates on board, as I was out in the world talking to developers, that there isn't a single centralized resource for everything you need to know about inference. And so I decided to sit down and write it because I like writing, and I thought it would be cool to have a book that I could hand people. I think that the main argument within this book is that inference is not one thing. It's not just an inference engine like VLLM or TensorRT LLM. It's not just a auto-scaling framework. It's everything from CUDA to infrastructure, from the on GPU optimization to all the distributed systems problems, all together in a single stack with the most tight latency requirements and the highest uptime requirements that you could possibly imagine. That's what makes it so cool to work on. And I just really wanted this book to, share my love of inference with the world and help people understand the complexity of these systems.
Yeah, I wish I had this book when I joined NVIDIA's inference product team 5 years ago.
Yeah.
Better late than never.
Yeah, well, I mean, at
Better
least
late
your
than never,
coworkers have it.
Yeah.
All right, guys, last question. So you're here obviously for a few days. What are you most excited about doing here after we hop off of the live stream?
Well, I'm going back to the booth and I'm going to give away some books. That's been pretty fun. And then I'm also just really excited to, I always at these conferences meet developers from all over the world and learn what they're building.
Yeah.
And it's exciting to see the adoption of open models in the real world when I'm talking to people here at this conference.
That's super cool. Jay, what about you?
Yeah, like Phil, I'll be also going to NVIDIA booth. I have a cool demo built on Gemma 4 and Google's ADK. So that's one thing. And the other thing is talking to developers and understanding what they are excited about the agentic workflows and what are the pain points so that I can close those using tutorials through my DevRel book.
That's super cool. And for those listening along, please do check out our NVIDIA and Google Cloud community on cloud developers. And with that, thank you, Philip. Thank you, Jay. This has been super fun to have you on here and talk about all things inference for it. Thank you, everyone.
Yeah, thank you.
Thank you.
All right, talk to you guys
Good
soon.
stuff.